This is the equation for a projectile, which could be a basketball, pumpkin, or soccer ball, or etc., modeling its height, h, in terms of t. H is your height at any time. H naught is your starting height. This is basically your y-intercept. Velocity naught is your starting velocity, which is normally feet per second. It is multiplied by t, which is time. You add together h naught and v naught times t. That was a mistake. Anyways, negative 16t squared is your gravitational pull down. You subtract this from h naught times v naught. Yes. And this is your beautiful equation for a projectile. To calculate velocity, you use the same equation as for the projectiles. However, you need some units. To calculate velocity, we need either its starting height or the time. Yeah. Scratch that, sorry. You need your starting height, and in addition to that, you can have either your height or your time. Okay, now we have our data points, so let's solve this. This might take a second. Give me a second. Okay, I've added time in, so our time's gonna be 2 seconds. So now let's try this. Sixteen times 4 is 64. Do plus 64. Can you see that still? No, you can't. Still can't see that. Hang on. I apologize in advance for the rest of this video and all the suffering you'll have to endure while grading this. Divide this by 2. What's that? Three? No. Let me math, hang on. And here we have our finished product with work shown. Woo! This is how to interpret quadratic graphs. Woo! When we're solving a quadratic graph, we are finding the x-intercepts, which is where the parabola touches the x-axis at any given y equals point. So to solve equations that are both formatted y equals ax squared and y equals ax squared plus c, where you have to get the x alone and solve for the square root. If the square root equals 0, then it's just 0, there's only one solution. But if it's a negative, there's no solution because you can't get a square root of a negative. Here we have our example, 2x squared plus 10 equals 210. We subtracted the 10s, then divided the 2 there. So we were left with x squared equals 100. Then we do the square root to get rid of the little square, and we are left with x equals 10 because 10 times 10 equals 100. This is if your equation is y equals ax squared plus bx. You solve it by factoring, which we'll see in a moment. And for you to solve it, this must be 0. Here we have our example. Factoring is basically anti-distributing, so we anti-distributed that into this, which still equals 0. And then we took the 5x equals 0 over there and solved that, so we got x equals 0. And then the x plus 1 equals 0 and took that over here, simplified that. So x equals -1, so our final answer is x equals 0 and x equals -1. Boom, interpreting quadratic graphs. I'm going to show you how to identify graphs for two different equations. The first one is y equals ax squared plus c. C moves the graph up or down on the y-axis. Up if it's positive and down if it's negative. The a in ax squared determines a lot of things, actually. If it's positive, then the whole parabola is positive, so it's a happy smiley face. But if it's negative, then it's a sad smiley face. And depending on how its size determines the width of the parabola. If it's smaller, then the parabola is fatter. If it's bigger, then the parabola is skinnier. For the equation y equals ax squared plus bx, the a does the same thing, whereas the bx moves the graph left or right because it's an x-intercept and not a y-intercept, which moves the graph up or down. This is how to tell if a function is quadratic or linear. You basically want to combine like terms, and in the end, if it's a sum, so x plus x equals 2x or something else, then it is linear. If it's a product, so x times x or 3x times 8x or whatever, then that equals x squared, which is quadratic. Okay, so this is how to distribute and double distribute, but let's get to that later. Distributing is really easy. You're just, if this is our example, then we're gonna just move that over there and over there. Distribute it, so x times 3x minus x times 5, which leaves us with 3x squared minus 5x. You want to distribute first. Double distributive is also called FOIL because here at CSPA we love acronyms. FOIL stands for front, outside, inside, last. No, first, outside, inside, last. Close enough. And it turns into this. Ta-da! So it's front, the two x's are in the front, outside, the two outside numbers that are the bread to our sandwich, the inside, which is the meat to our sandwich, and the last, which are the last two numbers in each thing, expression, whatever. When you simplify all this out, then this is your final answer. I don't really want to dive deep into this one because I have to go in like 10 minutes. So factoring is basically just undoing the distributive property. You want to pull out a common factor, which is at least an x, and then check your work with the distributive property. So the example I have here is 5x squared minus 25x, and both of those can be divided by 5x. So the 5x is on the outside, and then what's left is on the inside. So 5x times x minus 5. When we check it with the distributive property, we just distribute the 5x to the x and the negative 5, and then which leaves us with 5x squared minus 25x, which is the same thing as, guess what? This. Now we're gonna solve some quadratic equations, but now I realize that this is basically the same exact thing as interpreting a quadratic graph to find the x values. So I think I'm gonna skip this one. This is how to quadratic formula. This is the beautiful quadratic formula. It's x equals negative b over 2a plus or minus square root of b squared minus 4a times c over 2a. Boom. Okay, I just came up with a random equation, so the one we're gonna be doing is y equals 8x squared plus 4x plus 1, and these are our values, so here's what we'll be plugging in to the quadratic formula. Okay, so here's the quadratic formula with our units plugged in. So give me a second, and I'm gonna simplify this, and then we'll see what happens. I'm sorry I picked a faulty equation. So sorry, Miss Maniaci. Pat pat. This does not work because 16 minus 48 is a negative number and you cannot have a square root of a negative number. But if this had worked out, then, give me a sec. I understand that this is illegal, but I had to. I'm sorry. So 52 minus 48 is 4, and the square root of 4 is just 2. So then we would get negative 4 over 16 plus or minus 2/16. So I'm gonna simplify this really quick. Okay, so our final answer is x. Our x's equal negative 2/8 plus or minus 1/8, which leaves us with x equals negative 3/8. Yeah, and x equals negative 1/8. So, boom, yeah, chakalaka. Thank you so much to... Sorry about that, can't talk. Thank you very much to both Miss Maniaci for making it this far, and to Miss Kowalczyk and Miss Ackerman for letting me use their markers. Thank you. And also my mom, who's been waiting half an hour to pick me up. So, bye!